when adding and subtracting rational expressions, the process is the same as it is for adding or subtracting fractions. You're going to find a common denominator and then multiply each fraction or each algebraic expression, rational expression, so that the denominators are the same. That also changes the numerators, and then add the numerators. So for this, I want to look at the factors of 7x. And those are 7 and x. What are the factors of x squared? X times x. So to find the lowest common denominator, I'm going to take the one that's common, which is the x, and then the ones that are there individually, 7 and x. So I actually end up with 7x squared. That's what I want to change both of these into, is 7x squared. So I take each factor from the denominator. But if it's there in both denominators, like this x was, I only take it once, and then I take every other factor from the denominator. So this I want to change into 7x squared. What do I have to multiply the first denominator by to change it into a 7x squared? X. So I'll multiply by x on the top and on the bottom. Multiply by x. 1 times x is x. So that's the new numerator. I'll take the plus from there. And then what do I have to multiply the x squared by to change it into a 7x squared? 7. So multiply by 7 up here and down here. And I end up with 1 times 7 is 7. So I end up with x plus 7 over 7x squared. And that one's actually done, because there's nothing I can do to simplify x plus 7. The only thing I'm missing is, what am I missing?
The thing that doesn't equal. What it can't equal.
Right, what it can't equal, the non-permissible value. So x cannot equal 0 in this case. The instructions here are written out of how we're going to solve this one, because it is a bit more complicated. The first thing you need to do is find a common denominator. We already know that. But we do it here by factoring the denominators. So to start with, let's factor those. Leave the numerator as is and factor the denominator. This will factor to x plus 6 and x minus 2, right? And the other one, x plus 2 and x minus 2. Once you have it factored, you can do the same thing that we did before. It says use each factor from the denominators to make the lowest common denominator. So the first one is x plus 6, x plus 2, and the second one is x plus 2, x minus 2. So you take the one that's common, if there is one that's common, and just use that once. So for the lowest common denominator, x plus 2. And then use every other factor once as well. So we'll use the x plus 6 and the x minus 2. So what I've done is just expanded x plus 2 times 2x plus 2 times x plus 2 to get this 2x squared plus 4x plus 2x plus 4. And then expand the x plus 1 by x plus 6 to get x squared plus 6x plus x plus 6. That's expanding the whole numerator. And then copy the denominator. It actually needs to be there in every step. That's the expanding of the numerator. Now we need to simplify the numerator. So we'll do that by combining like terms. I have 2x squared there and an x squared here, but it's subtracted, right? So 2x squared minus x squared is x squared. And then if we look at all of the x's, there's 4x and 2x. That's 6x. Minus 6x because of that negative. And then minus another x, so I guess it's just negative x. Is it? And then 4 and negative 6. So negative 2. and then the denominator's still there. Sometimes we have to simplify further. I'm just going to move that up a little bit so I have some space. This x squared minus x minus 2, I think we can factor that, can't we? So we will factor it. If you can factor it, this is still the simplifying part. If you can factor that, factor it. So this is x minus 2 times x plus 1. And then it's over x plus 2, x plus 6, and x minus 2. Do you see why we do that? Because what can I do now to simplify it just one step further?
Just cancel.
Get rid of those common factors. Reduce by that common factor. So we're left with, as our final answer, x plus 1 over x plus 2 times x plus 6. And then non-permissible values, x cannot equal negative 2, negative 6, and 2. We're going to do one more. Here it is. So, what's the first step? Factor. That's, in this unit, that's almost always the first step, is to factor, at least the denominators. So this becomes x over x plus 4, x plus 5, minus 4 over x plus 4, x plus 3. So here's what we're going to do for the lowest common denominator. Take the first denominator, x plus 4 and x plus 5. Take the second one, x plus 4 and x plus 3, and find the common denominator by taking each factor from those lists once. X plus 4 is there once, so that's part of the common denominator. It's in both of them, but it's only there once in each. So we take that, and then take the other two. The x plus 5 and the x plus 3 also have to be part of it. So there's the new denominator. So now we need to look at how do we take each of the denominators that we already have and change them into the new one. And we have to do it by multiplying. But the first one is already x plus 4 times x plus 5. What does it need to multiply by? So which factor is missing from that one? X plus 3. There are 3 factors there. It already has 2 of them. So x plus 3 is the one that's missing. That's what we're going to multiply by. So multiply this by x plus 3 and this by x plus 3. We get here just x times x plus 3. So then take a look at the second denominator. The second denominator is x plus 4 times x plus 3. So if you look at the common denominator, it has the x plus 4 already. It has the x plus 3 already. It's missing the x plus 5. That's what we multiply by. Because that changes the denominator into what we want. X plus 4, x plus 5, x plus 3. So on top, it just looks like, take that minus, and then 4 times x plus 5. Because we have to multiply by the same thing on the top and bottom to keep it equivalent. Right? We multiply by 1, which is x plus 5 over x plus 5. Then it's a matter of expanding and simplifying. So now let's expand that. X squared plus 3x minus 4x minus 20 and keep the denominator there. This one's a little easier because it's a each of the original numerators were just a monomial, one term. So the multiplying and the expanding is easier. Now just combine terms. X squared minus x minus 20. I think, yeah, we could factor that numerator as well, right? That numerator should factor to x minus 5 and x plus 4. Oftentimes you won't be able to factor the numerator, or if you do, nothing will cancel out. But here that x plus 4 can disappear. We're left with our final answer of x minus 5 over x plus 5 and x plus 3, where x cannot equal -5, -4, and -3. So that part is the final answer.